I'm going to demonstrate several networking options in VirtualBox, specifically network address translation, or NAT, which is the default option, bridge mode, and an internal network. And I've got Ubuntu Linux servers already installed, and I'm going to use them. They're essentially equivalent, except they've been configured with the different networking options. We'll go through NAT first. Just if we go to the settings in VirtualBox, we can see that under the network settings, the default is that an adapter is attached to NAT, or network address translation. And this allows the guest computer to have internet access from a client's perspective. It can access the real external internet, but generally real devices on the internet cannot access this internal guest device. So this is normal for setting up a virtual machine for browsing for a client usage. The default settings are normally sufficient. We will see later that we can enable port forwarding so that external hosts can access specific services on the guest. So let's just see that operating. If we start that node, note that I've already saved it in a start position, so when we boot it up, we'll just log into this Linux node, and I'll bring it across. And I'll just log in and get the right username and the password, and I'll just look at my IP address using ifconfig. And note in the second line there of the output, the internet address, the IP address, is 10.0.2.15. So this is the IP address that's been allocated to my guest. And how NAT actually works is that VirtualBox runs a DHCP server allocating IP addresses to the guests. Just to see the difference, so my host computer, my actual computer, I can either open the command prompt in Windows and run ipconfig and see my real IP address, the public internet address of my physical computer is 138.77.176.56. Whereas the guest Linux machine, when we use NAT, gets an internal address. And it's set up such that the real computer cannot, or external computers on the internet cannot access this internal guest. Just to see that we can have internet access from my Linux computer, the guest, I can access websites, or I can ping real computers. For example, if I ping Google, and we get a response. So I have internet connectivity, but external computers will not be able to connect between devices in VirtualBox, and also to allow external devices to log in. And if I try to ping, if I bring up my command prompt and ping, my Windows computer has in the background here, I've got a picture that shows the connectivity, noting that the guest I list here is Kali Linux, but it's just a Linux guest in this case. My host computer is Windows 10, and I'm using NAT. So from the real internet's perspective, what happens is my host computer is allocated an IP address. In my picture it's 1.2.3.4. In my real computer it was the 138.77.176.56 address. So that's the real address allocated to my computer. What VirtualBox does is it acts as a router and a DHCP server, and also does network address translation. So when you start your guest, VirtualBox router acts as a DHCP server and allocates an IP address within some range defined by VirtualBox. In this case, 10.0.2.15 for my guest. Whenever that guest tries to communicate out to the internet, for example, when I ping Google, it uses the source address of 10.0.2.15. But when it gets to the VirtualBox router, it implements NAT, which changes the address, translates it to the public 1.2.3.4 in this example. And when the response comes back, NAT does its job and forwards it back to the guest. Without port forwarding set up, no one on the internet can access my internal guest. We can enable port forwarding so specific services on the guest can be accessed from outside. The next mode of networking I'm going to show is bridged mode. So I have my second machine here. I'll start that up. Actually, before I start it, let's look at the settings. The network settings in VirtualBox, the adapter is set to be a bridged adapter. And we actually choose the real adapter on the host computer. In this case, my gigabit Ethernet adapter. If you're using Wi-Fi, then you may choose your Wi-Fi adapter. And what VirtualBox will do will bridge that adapter with the network interface in the guest machine. And again, the default settings are normally sufficient. So I'll start my guest and we'll have a look and see what happens with regards to the IP addresses. Remembering my host is with this 138.77.176.56 address, which is an IP address allocated by my real network DHCP server inside the university. So if I log in to this Linux machine, if we run ifconfig, we can see I have an interface, this ENP0S3 interface, and the second line shows the IP address, this 138.77.176.66 address. Noting my host .56, my guest .66. What's happened here is that with bridging mode, VirtualBox essentially brings the guest network adapter onto the real network, and as a result, the real DHCP server in my LAN has allocated an IP address to this guest within the same network address as the host address, this 138.77.176 network address. Just to check, again with this mode, we essentially have full connectivity as the host does. So I can ping, I have access to outside internet websites, and other devices on the network will be able to ping and contact my guest device. So for example, I'm on my Windows host and I'm going to ping the address of the Linux guest, 77.176, and the guest is .66, and it's getting a reply. So we have connectivity from the host to the guest, because it's as if the guest is on the same network as the host. What's happening here with bridging, if I bring up a picture of this, we have our Ubuntu Linux guest, we have our Windows 10 host. The DHCP server for my real network has allocated my Windows 10 host, the IP address in this demo or in this example picture, 1.2.3.4. And what bridging does is it essentially joins that so that when the Ubuntu Linux guest sends out a DHCP request, it is forwarded on to the real LAN, and the real DHCP server sends back a response and allocates an IP address, say 1.2.3.5, or the .66 address in my example. So it's as if we now have two computers on the real LAN, my Windows 10 host and my Ubuntu Linux guest. And with that, if we have multiple guests in VirtualBox, they'll be able to communicate with each other because they'll be all within the LAN, and say the next one would be 1.2.3.6. It would be able to talk to the other guests as well as the host and other devices inside that LAN, other real devices. So this is much easier to allow networking amongst devices both inside VirtualBox and inside the same LAN. In theory, hosts out on the internet, when we're using bridged mode, can also contact the guest. However, in practice, it will depend upon your real network. If you're in your home network, your home router may block that. You would need to set up that router to allow external internet hosts to access the internet. So let's look at the third mode, which is similar to bridging, where we can set up a network and have the different VirtualBox machines communicate with each other, but a little bit more secure in that we don't use the host IP range, we have an internal network. So I've got another node here, and what I'll do is also use the NAT node and set that to talk to the Ubuntu Linux internal host. So let's look at the settings for this third Linux guest. We go to the network settings, and I've set up the adapter to use an internal network. So not NAT, not bridge, but an internal network. And here you should choose a name of the internal network. And I've just called it Demo Net. The other settings are the default settings. The idea is that all guests that you want to be able to communicate with each other, you can put them on the same internal network. And I'll do that in a moment for the other NAT device. So let's start this one and see what happens. So it's not going to use NAT or bridging, it's going to just connect to an internal network, which should allow it to communicate with other VirtualBox machines on that same internal network. Bring it across and it will boot up. So it doesn't necessarily have internet connectivity. And we're booting up. We'll wait for it. And we start to give this something being slightly slow here. Start job is running for Ray's network interfaces, and it says it's going to wait up to 5 minutes, 5 seconds. It's trying to set up, automatically set up the network interface. And because we're using internal networking, it's not going to be able to, so basically it's trying to get a DHCP address from a server. That's not going to work because we're using internal networking. So this is going to run for 5 minutes and then give up. So I'll just pause now and then we'll explain a way to overcome this problem for the next time. While that node is waiting that 5 minutes, let's look at our other node. We'll look at the settings. This is the NAT Linux node. Adapter 1, we're going to use NAT. I'll leave that. I'll use a second adapter, so a second network interface. I'll enable that and attach it to an internal network and make sure the name matches the one we gave for the other node. The idea is that VirtualBox will set it up so that this network interface is connected to a virtual switch, which is then connected to the network interface for our internal node. They'll be on the same LAN. So we can start that node. Noting that our other one is still waiting that 5 minutes, so we'll boot this one and set it up as we wait for that. This one has NAT enabled as well on the second interface. Note there it has 2 interfaces. We'll see more detail shortly. But the NAT one allows the DHCP server to allocate an address. In this case, the VirtualBox DHCP server. So I'll log in. And we'll just look. We still have our internal address allocated by VirtualBox 10.0.2.15. But if we use ifconfig to see all interfaces with the -A option, we see that there's another interface, EMP0S8, which has no IP address. This is this second adapter, which is going to be on the internal network, demo net. It doesn't have an IP address. We would need to give it an IP address. And there are different ways to do that. One way, we can use the command line program ifconfig. Another is using the command line program IP, and another is to configure it in a file so when your computer boots it automatically gets that. let's use ifconfig as a quick way. I want to configure that interface P0S8. I want to give it an address, and I'll just give it a 192 address, 168.1.1 net mask. So I need to manually set a static address, and broadcast if we like, but no, it'll come, and that interface is currently down, so I'll specify it to be up. So that is configure this interface to IP address 192.168.1.1 and turn this interface up or turn it on. And to do that, we'll need to be sudo. I'll proceed the command with sudo. And it's asking me for my password. Note it gave an error there about sudo. That is because I've actually changed the host name to NAT demo without changing the corresponding file that sudo looks at. So it's confused about NAT demo because before it was just called demo. It's not an error, it's a warning. ifconfig. This second interface, ENP0S8, has an IP address 192.168.1.1. It should be attached to our demo network, our internal network, and we're going to use it to talk to the other Linux node once that's up and running. Let's see, did it get through the 5 minutes? Yes, it's gone through the 5 minutes. So let's log into that one and see how we can configure it so it won't have to wait for 5 minutes the next time, and then get it to talk to our second Linux node. So I'll log in. ifconfig, let's see what we currently have. We have a single interface. It has no IPv4 address because what happened, when the system booted, it tried to get an address using DHCP. Because we set up internal networking, that wasn't possible. It actually gets an IPv6 local scope, link scope address, so a link local address, which is just allocated when you don't get a DHCP response. That's of no use to us. We want an IPv4 address. So we saw on the first node that we could set it using ifconfig. I'll show you another way which will also solve this problem of this 5 minute wait for the startup. And we need to edit a file. It's in the network, it's in the folder or directory etc/network. It is called interfaces. So I'm going to use the text editor vi to open the file called interfaces within the directory /etc/network. And to edit this, I need to be administrator, so I need to proceed the command with sudo. And it asks for my password. And this is the interfaces file. And this is looked at when your system boots. I'll just quickly explain what's here, but not all the syntax. These two lines are showing to automatically enable the loopback interface. This is for localhost. This is for the first network adapter, which is on the NAT settings in VirtualBox. It's saying get your internet address using DHCP. So ask the DHCP server, and that one works. And that one doesn't work on this Linux node. It works on the NAT one. So that's where our problem was. It's saying ask the DHCP server, but we have set up an internal network where it won't be able to connect to a DHCP server. So that's the problem here. And what I'm going to do is I'm going to comment that out. I for insert and insert a hash there to comment those two lines. And I've already, as you see, written the replacement lines. I'll explain them. What I want to replace this setting with, instead of saying get the IP address from a DHCP server, I want to statically assign the IP address using this static option. and I specify in the next 4 lines the values I want to give it. The IP address, the net mask, the network address, and the broadcast address. In that case, when the system boots, it will read this file. It will see we don't need to ask a DHCP server. We statically assign the IP address, and it won't wait for these 5 minutes to boot up. And of course, I don't need to use ifconfig like I did in the other Linux node. I will automatically have this address. So let's try that. I'll write that and quit, and I'll reboot, and let's hope it boots faster than the 5 minutes. Shuts down and then starts up again. Remembering the Linux node on the left has the IP address on the internal network of 192.168.1.1. And let's log in. See, we didn't have to wait our 5 minutes there, so we've avoided that problem by statically assigning address. And run ifconfig. We have the address 192.168.1.11 in this case. And they both should be configured to be on the same virtual network or the same internal network, which is our demo net. So let's see if they can talk to each other. So here we'll ping 192.168.1.1. And sure enough, we get a response. So we can communicate between the 2 VirtualBox guests. And of course it should work. Okay, so with internal networking, we can use that to set up so the guests can communicate with each other, but they don't necessarily have internet access. Now our left-hand node, the NAT demo, does have internet access because it has 2 adapters. It has the NAT adapter and the internal network adapter. So we can still ping, say, Google. So we do have internet access as a client from the NAT demo Linux node, but from the internal only demo, if we try to ping Google, we get no response because this one only has a single adapter and all it knows about is the internal network. And we can see a little bit more detail if we look at the routing table using a route on both nodes. On our internal only node on the right hand side, internal demo, it has a route, or it knows about the network 192.168.1.0. It knows about its local LAN only, and it can therefore only communicate with other machines on that same local LAN. The NAT demo node also knows about 192.168.1.0, so it can talk to the internal only node, but it also has a route or a default gateway to 10.0.2.2, which is the VirtualBox NAT router, which then forwards out to the real internet. So with the NAT demo, we can communicate with the internet. With the internal only demo, we can't at this stage. But we could configure the routing table inside the internal only node so that it is aware, or it can go via, say, the gateway in the NAT demo, or we could enable the second adapter and allow it to have a NAT. So we've gone through 3 options of using NAT only on a Linux node to allow essentially client-only access to the internet. Bridge networking, where we have the guest having essentially client access to the internet plus communication with other nodes inside the VirtualBox and inside the real network. So we can potentially have other nodes accessing servers on the guest. And then we saw internal networking, where we can have the VirtualBox guests communicate with each other. They can have internet access if we also enable the NAT on the adapter. We may need to do slightly more settings if we want to allow them to communicate with each other and with nodes outside the VirtualBox. Which one to use? If you just want a single node and you want to run it as a client, then probably NAT is sufficient. If you want a more complex VirtualBox network or a virtual network of nodes, then you may use bridge mode. It's probably the easiest to set up. If you want to be a little bit more controlled or secure, where you don't want the internal nodes to have the same network address or same IP address as on your real network, you may use internal node, but it does require some additional routes to be set up. With NAT mode, hosts cannot access the guest unless we enable port forwarding. So to finish off, look at port forwarding. So to demonstrate this, I'm going to use a secure shell server. So I'll install that. So I'm on my NAT demo node here. I'm going to install the OpenSSH secure shell server. And what I want to be able to do is from my host machine, log into the secure shell server. It looks like I may have installed it before. I'll shut down that and enable port forwarding. Actually, before that, we'll try and test. So I'm going to open up a secure shell client inside my host machine, my Windows 10 machine, and we can do that using, for example, PuTTY. We'll open up PuTTY. And our IP address, the problem being, if we try to connect to 10.0.2.15, which was the IP address of our guest, then from our previous settings it doesn't work. We'll try. And I'm bringing it across. It's trying to connect from my Windows 10 host to 10.0.2.15, but in NAT mode by default it cannot do that. So that's not going to respond. It will eventually time out. I'll give that up. We need to establish port forwarding to allow that to work. I'll power off my machine and then go to the settings, and in network settings and our adapter under advanced we have the port forwarding option, and we'll add a rule here. We can give it a name, secure shell. The host, secure shell, uses TCP. What we need to set up and be careful with is the ports. So what I want to say, anything that goes to my local host in a particular port, I want to redirect it to the guest. So the guest port is 22 because I know secure shell servers run on port 22. The host port, I'm going to choose a different one. Generally you can choose anything as long as it's not used by other services on your host computer. I'm going to choose, let's say, 5022. And we'll show how that works. So that, for example, if I'm running a secure shell server on my host computer, there won't be any confusion. So redirect anything that goes to port 50222 to the guest port 22. So we have port forwarding set up. Actually, before I forget, in port forwarding, we should also complete set the host IP. This is important. 127. That is the local host address, saying if someone runs a secure shell client and connects to the actual local host, that is the Windows 10 host, and at port 5022, then redirect to the VirtualBox guest, this particular guest, and redirect it to port 22. So include the host IP address there, and we'll start our machine. And while that's starting, we'll start PuTTY. And here we specify the localhost address. Basically, from my Windows client, I'm going to connect to the localhost, the Windows computer, but to a particular port, 5022, and it's actually VirtualBox that's listening on that port, and VirtualBox knows, because we enable port forwarding, anything that comes in on port 5022, send it to the guest, the NAT demo guest, and to port 22. Let's make sure our node is up and running. That is, and let's open that, and I'll just bring this across. It's come up on my other screen. It comes up with a warning saying I'm not aware of that. Do I really trust it? Yes, we really trust it. And now party's coming in as the login. So it's actually logged us in now, or sorry, it's connected us. Now we log in, and I'm on NAT demo. So this allows nodes, in this case my Windows 10 host, to connect to a server on my Ubuntu Linux guest. And in theory, anyone out on the internet can connect to my Ubuntu Linux guest. In practice, your, say, home router, or in my case, my university LAN router, would most likely block people out on the internet accessing the internal network. But from my Windows 10 host, I can log in and as if I'm sitting at the computer. So port forwarding allows specific cases where we can access the guest from outside. So now you can choose from the different options for setting up a network, depending on whether you want to run a single simple node. You may use NAT, possibly with port forwarding. If you want to run multiple nodes, you may use bridged or internal networking. And you may still use port forwarding if needed.